Okay, welcome back to your applications of logarithms. We're now going to start looking at exponential growth and decay. So it says, during the early years of a community, it is not uncommon for a population to grow according to the law of uninhibited growth. The law of uninhibited growth, in essence, just means, hey, we've got continuous growth. According to the Pansville Wikipedia entry, in 1860, a village of Pansville had 2,649. In 1920, the population was 7272. Use these two data points to fit an exponential model, A of t, and the number of Painesville residents, t, after years after 1860. Use t sub 0 to represent the year 1860. Round k to 4 decimal places. So in these ones, we use this formula a equals a sub 0 e to the kt, but really it's similar to your continuous interest. So think about that a as being your initial amount, which in this case is 2649. We've got e. K we don't know, and it indicates in the problem here we're going to actually find out what the growth rate is, but we do know the years. So let's think for a minute. If we've got 1920, we want to see how many years it is from 1860. Let's subtract it, and we end up with 60. So we're going to have times 60 in the exponent, and we know how many people there were at the end of that time. That's 7272. So let's think about solving for k. Let's divide both sides by 2649. I would probably leave it as a fraction. If you start rounding too early on, these answers do become drastically different. So let's leave that as 7272 divided by 2649 equals e to the k times 60. At this stage, we want to get k out of the exponent. The way we do that is we take the natural log of both sides. So we get natural log of 7272 over 2649 equals k times 60. So how do you think you get k all alone? Divide by 60. As you type in your calculator, natural log of 7272 divided by 2649, make sure to close the parentheses before you divide by 60. We end up that k is approximately 0.0168. There's a 3 after that, so we don't need to use that. Okay, so we're now saying, okay, hey, I have the model. A equals my initial value of 1649. E, my k is 0.0168, and I've got a t. So now if we're saying, okay, well, how many people, what's the population in 2010? We want to figure out how far is 2010 away from 1860. So when you subtract those two, we end up with 150. So all we're saying is take that model and plug in 150 for t. So when you do that, and you do 2649 e to the 0.0168 times 150, we end up with 32923.35. Okay, we know we can't have 0.35 of a person. In this case, I will accept two things. Oftentimes, the people will always round down. Otherwise, if you round according to rounding rules, I'll accept either one. In this case, it ends up being the same of 32,923 people. Okay, let's look at the next one. The next one says, hey, chromium 51 used to track red blood cells. The initial amount is 75 milligrams, and its half-life is 27.7 days. So this idea of half-life is that it literally is half the amount in a period of time. So find the decay constant k. Let's go ahead and we're going to set 75 milligrams. The amount is equal to, oh, sorry, I messed it up. Okay, so our initial amount, 75, is going to be equal to some amount that we haven't discussed yet. Okay, with that in mind, we've got E still, because these are decay and growth. We're trying to find K, but we're timesing K by 27.7. If that's easier for you, you're definitely welcome to write 27.7 K. Okay, but this is equal to half the amount. So you can think about that as being 75 divided by 2. Literally, it would be half of that. I think people kind of like decimals better than fractions, so I'll write that as 37.5. because that one does write out nicely. So once again, you're saying let's solve for k. So let's divide both sides by 75, and we get a half, or 0.5. Hey, start noticing. Notice that half is because we had a half-life. Remember when we were doubling, we got 2 over there, is equal to e to the 27.7k. So now, we're going to take natural log of both sides. So the left side will cancel, we get natural log of 0.5, so right side will cancel with the e, 27.7k. To get k, let's divide by 27.7. So k equals natural log of 0.5 divided by 27.7. You type that in your calculator, being sure to close parentheses as needed, and we get negative 0.0250. Notice it is negative because it is getting smaller. So if we wanted to talk about the equation, we'd have a equals 75, e to the negative 0.025 t. Okay, determine how long it takes. So here we're going to be looking for t, right, to get 90% of the material to decay. Round your answer 2 decimal place. Hint, if 90% of material decays, how much is left? So think about 75 times 0.90. And you're really saying, hey, 67.5 here. But be careful, we're saying that's how much has decayed. So there's really 10% left. So you're thinking about 75 minus that, right? So we get 7.5, or you could have done 75 times 0.10 to start with. All right, with that in mind, we're going to set 7.5 equal to this equation of 75e to the negative 0.025 t. So let's divide both sides by 75, and we get 0.10. Notice, because we've got 10% of the material left equals e to the negative 0.025 t. How do you get rid of e? We'll take the natural log. Natural log is log base e of 0.10 equals negative 0.025 t. You divide both sides by that negative. And you may be like, oh, that's kind of weird, I'm dividing by a negative, but if you take natural log of 0.10, that is also a negative number. So it all ends up working out. We will get a positive time here. So natural log of 0.10 divided by negative 0.025 equals 92. In this case, since t was days, we're going to round it as, it says 2 decimals, sorry, 92.10 then, so 1 days. And it's got to match the time here, so since that's days as well. Okay, let's look at, we got 2 more examples here. An unknown radioactive element decays into non-radioactive substance. In 500 days, the radioactivity decreases by 68%. Okay, so what is the half-life? So be aware, once again, when it says like it decreases by 68%, we're really saying there is 32% left, right? That's 100 minus 68 is 32. Okay, so we're saying, okay, when I get left of 0.32, okay, so you got a couple options here, I guess I should say. So when I think about the amount, I think it's always easiest to think about like 1 as the starting amount. So if 1's the starting amount, we've got 32% left, we've got 0.32 left. Your other way to think about it is that you could start with 100 and then say you've got 32 of it left. But I would just choose some starting amount that's a nice, easy number to use. And we're saying that's E. We don't know what the decay rate is, but we're going to say, hey, it took 500 days for that to happen. Okay. When you just got 1 out the front, it really doesn't even need to be there. So if I'm trying to solve for k, I'm just going to do the natural log of both sides. So natural log of 0.32 equals k times 500. Let's divide both sides by 500. Okay, this time I'm actually going to leave k as being this integer. This value of natural log of 0.32 over 500. Because there are sometimes in the homework where it doesn't tell you to round k, in which case I would leave it exact, otherwise you'll get a slightly different answer. So now it asks us to find the half-life. So this is like part 2. So if we wanted to figure out the half-life, I now have, let's start being smart. Okay, we said, okay, if I use 1 as my initial value, what's half of that? It's going to be 0.50. So then I don't need to write the 1 out front, but I'm going to have e to this natural log of 0.32 over 500 times the time. And we're trying to figure out what is the half-life of the element. So how many days is it basically? So now if we want to take natural log of both sides, that will cancel. So I have natural log of 0.50 equals natural log of 0.32 over 500 times t. You've got two options. You can either divide by that natural log of 0.32 over 500, or you can think about as timesing by that reciprocal, right? So these would cancel. Gotta do the same thing over here. The 500 divided by natural log of 0.32. So then we can type in our calculator 500 times natural log of 0.50 or 0.5 divided by natural log of 0.32. Okay, so start typing that in. And when we get an answer, we've got that t, or the time, equals 304.16. Since it originally was in days, we've got days again. Notice here, 500 days, they had 32% left, so does it make sense it's less days? Sure enough, it does. So the next question is, how long will it take 100 milligrams to decay to 71? So once again, similar to what we did with the half-life, but this time we're going to have 71 equals 100 e to that natural log of 0.32 divided by 500 times time. Divide both sides by 100. We get 0.71 equals e to the natural log of 0.32 divided by 500 times t. Okay, then you're like, well, what do I do next? I'm taking the natural log of both sides. So natural log of 0.75 equals natural log of 0.32 over 500 times t. So will you multiply by the reciprocal or divide by that lovely fraction? I'm going to get 500 natural log of 0.75 over natural log of 0.32. So when you type that in, we end up with t is 150.29 days. Okay, I do always like to kind of have you try one on your own. So this one, let me get you started, and I'll kind of give you a few answers along the way, and then I'm going to let you guys kind of figure things out. So a wooden artifact from an ancient tomb contains 60% of the carbon present in living trees. How long ago to the nearest artifact was it made? And it tells you the half-life is 5,730 years. So they want to know, when do we have 60%? So when does 0.60 equal e to the k times t? The issue is I need t. I want to solve for t, how many years, but I don't know k yet. So we're going to actually have to take one step back and say, okay, the half-life. So I've got 0.5 for half of it equals 1. I don't need to write that, e to the k times 5,730. I'm going to let you solve that. I'll give you the answer for k down here, though. You should get the natural log of 0.5 all over 5,730. Once you have that, think about plugging it in there and solve for t. So I will give you your answer for t as well. I would leave it in that exact format again, just because I know sometimes, depending on the question, if it doesn't tell you to round it, you'll get things slightly off. So t to the nearest year is 4,223 years if you've done things correctly. All right.